Cody Powell. I am an associate professor in chemical engineering and an EGI affiliate faculty member. The Forge group is a really tough act to follow, not just because their work is so impactful, but because they leave you with so little time to speak. I kid. So my talk is actually a little bit less technical and maybe a little bit shorter, so hopefully you'll be thanking me. I will also have my colleague Masoud Parvania from electrical engineering sharing the time with me. So as you all know, the energy landscape is changing really, really fast. So I just put together some recent little blurbs. City of Chicago committing to 100% renewable energy. I could probably find 30 different cities that are making these same kind of commitments. The Biden administration targeting industrial decarbonization, low carbon fuels, and then CCUS as well. California approves a wave of aggressive new climate measures. So it took me all of 5 minutes to come up with some of these headlines. I want to point out that I just got tenure this summer, so I feel a little more comfortable sharing this next slide. I think we might be changing a little bit too fast. The world is really changing very fast. So these are some other headlines that we found over the last few months. Some of these were leading into this summer. So rolling blackouts could happen in California if things get dire on the power grid. Here's what they are and who's affected. Much of the U.S. could see power blackouts this summer. A grid assessment reveals American West should brace for a blackout summer. Electricity regulator warns. This one, Europe's banks dim lights as they brace for a winter blackout. This one is more related to what's going on with Russia and Ukraine. The FERC chair on the grid, the old way doesn't work. So the world is changing really, really fast, and my research is targeted at, okay, how do we navigate all of this in an effective way that doesn't make for a reliability disaster. So what's causing this? This is data that I've been sharing since graduate school. This is solar energy data collected from the top of my building in Texas. So we know that if we're relying on intermittent renewables like solar and wind, we can't control when those are available. So we've got to adjust, come up with storage or adjust our behavior in some way. If we compare that energy supply to the energy demand, this is also data from the state of Texas. This is over a 24-hour period. You're seeing even demand itself fluctuates quite drastically, and this was a fairly extreme day, I will admit. So we have this really unique challenge when we're trying to pivot toward renewable energies in trying to make the supply and the demand line up in a way that we can still maintain our way of life. So how would this impact your business, all this climate that we're facing? So certainly by improving your energy efficiency, that can impact your bottom line. I'm sure you've heard the term ESG, environment, social, and governance. A lot of companies are adopting these new kind of governing principles for their company where they are portraying themselves as not just being out there for profit, but trying to be a good steward of the environment. Renewable energy integration is certainly important. Decarbonization is language that we're hearing a lot more from the federal government. But then really, you want to know how this impacts the way your company operates. Certainly everyone wants to be a good steward of the environment and of our society, but we still have to find ways to make all of this work within our existing market. So here's how EGI can help. So my working with EGI represents EGI expanding or broadening its base of technologies and services that it provides. So I run a center from the Department of Energy that provides no-cost energy assessments to companies. So we can bring in a team of professionals and well-trained students to come in, survey your facility. We can look at different energy projects that you're interested in, and we can run some engineering and economic calculations for you to see not only how those would impact the environment, but also how those would impact your savings and your revenue streams. We, either as a result of those assessments or just as a targeted project, we can come in and we can do much more detailed engineering analysis for specific targeted projects by using some of the skills of simulation and analysis that we've developed. And then finally, we can partner with companies. As a university, we're always looking for industrial partners, and especially the Biden administration really wants to see these large-scale clean energy projects be deployed, and they're putting their money where their mouth is, so there's quite a bit of money out there. So at a university, we're trying to find partners. We want to do big, impactful projects like the Forge project, but we need industrial partners to help with those. So at a university, we're good at the grant writing part, but we need help to make these more integrated partnerships. So just to give some examples, I mentioned this Department of Energy program. This is called the Industrial Assessment Centers program. The University of Utah is one of, I think, 35 centers around the country now. We train teams, so this is kind of a half student training program and half providing an actual meaningful service to industrial partners. But we go out to visit industrial sites. We do this thorough, comprehensive survey of their facility, and we tell them, hey, we think you could do X, Y, and Z, and this is going to save you X number of dollars per year. We actually follow up with these companies after about a year, and we ask them, which of the things that we recommended have you actually implemented? And currently, our implementation rate hovers at about 55%. So companies actually listen to these things that we're doing. When I started this program, I was a little skeptical myself about how many companies would listen to us. But then when I got out there and we're working with these facilities people, one thing that we discovered was that everyone has so much on their plate. They have their hands full. So we come in and we're a separate set of eyes. And we may work with you and look at ideas that you're already looking at, but we'll just drill down and do more of the economic and energy analysis that companies maybe don't have the in-house resources for. So I extend this idea. We go out and we visit all these facilities. I am a research professor at the university, so I'm really interested in the different research applications from the things that we find. So I envision this smart grid concept, where the smart grid isn't just the electrical grid, but really the electrical grid and our energy infrastructure is interfacing with all these manufacturing, commercial, residential, industrial facilities. So I think there's a lot of low-hanging fruit out there. Instead of installing solar on every building and having humongous batteries to back everything up, I think we have a lot of resources out there where that if we just operate a little bit smarter, we could use some of the flexibility that we've already got in our existing infrastructure to be viable projects that help with this whole clean energy equation. So in this little animation, you can see these industrial facilities. So we've got a manufacturing facility here and another manufacturing facility here. They have built-in resources like their actual production lines. They could speed up or slow down depending on demand from the grid. Similarly, the one on the right, they have that tank that they're filling up. So companies using built-in resources can do things like run their pumps extra hard and fill up storage tanks when power demand is low, and then use that storage when power demand gets higher. So this is the way I'm trying to push my research group, is trying to quantify all the different opportunities that are out there and see what impact this could really have on the grid and on helping this whole thing work in a way that's more cost-effective and more reliable. So here's a case study. So although some of the rate structures from our electric utilities are a little bit archaic, there's still an economic case to be made for doing a lot of these things currently. So in Utah with our utility, and I think this is fairly ubiquitous nationwide, there's something called a peak demand pricing for electricity, where you're not just paying for electricity on a per kilowatt hour basis, but you're actually paying on a per kilowatt basis. And the way that works is the utility will look at an entire month of electricity usage. They'll find the 15-minute period in that month where you pulled the most power, and that will set this peak demand portion of your bill. The case study that I'm going to show you, they actually paid about 60% of their bill comes just from what their peak is. It didn't matter how much energy they consume for the entire rest of the month. That 60% was based on just their peak. So if they can do things like shift their peak, like use extra energy when demand is a little bit lower, so that they can use less energy when they are approaching their peak, that can actually be a significant financial benefit for them. So this particular company, I want to mention we're not supposed to divulge the names of the companies that undergo these assessments. So this was a mineral processing facility in eastern Nevada, and they are mining, they're pulling up minerals, they're running a processing facility. What they're doing currently is they're dewatering because they want to keep digging deeper in their mine. So they're dewatering. They recycle that water and pull it up into large, they have a total of 6.2 million gallons of water storage. So they use that water storage to feed their process, and they're using that water for the minerals processing part of things. Each of their wells is equipped with variable frequency drives on their pumps. However, what we discovered is that they're keeping those pumps maxed out at 100% all of the time. So while they have VFDs, they're not really utilizing the full flexibility that VFDs would offer. They wanted us to come out and do an assessment of a big solar project. So we mapped out and modeled a 6 megawatt solar farm because they had that ESG drive from their company. This is a European company. So we modeled this solar farm. We also looked at their real-time energy usage, and these are the results that we got. I didn't realize it might not. I hope you can see the yellow line on there. So the blue line is the power demand that they're currently experiencing. So this is over a period of about a week. The yellow line is how that would look if they installed this 6 megawatt solar farm. So I'll take volunteers here. Any volunteers want to speak up and tell me how that solar farm impacts their peak demand usage? So for this particular example, it actually doesn't. So this particular facility has an incredibly low energy charge. They're paying, I think, about 2.3 cents per kilowatt hour for their energy charge. And unfortunately for them, they have an extremely high demand charge. I mentioned that their demand charge is about 60% of their bill. So they're paying about $21 per kilowatt for their bill. So if they did this big solar farm installation, this particular facility doesn't follow any diurnal cycle. So the solar farm really doesn't help reduce their peak demand at all. And really the solar almost becomes a burden on the grid in some ways, where you still have this times where you need to have a lot of energy throughput, and this even though solar would be a distributed energy resource, it's not helping them particularly. So the natural conclusion would be they should install a battery system so that you could store that excess solar energy when it's available, and then use that battery system to draw down your peak. And that is a fine idea. A battery system for them at the size that they needed, I think we did a 2.5 or 3 megawatt battery analysis coupled with their solar system. The battery itself would cost about $3.6 million. One thing that we told them was, hey, you already have storage at your site, and you have the ability to make your system flexible the same way that a battery system would make your system flexible. So what we pitched to them was you could actually run your pumps, pump more water out during the low energy demand times, then you turn your pumps down as you're approaching your peak, and effectively you're using existing capital equipment that you already have to bring down your peak. I wish projects like these would get more attention, and that's what I'm pushing for. I don't think we need to be spending as much capital as we're proposing to spend when our industrial facilities already have a lot of existing flexibility. We just need to be smarter about the way we use it. So we ran the analysis, we simulated this system, we found that they could reduce their peak by just as much as the battery system would reduce it. But for really the only cost you need is going into your automation system. So you may need some new sensors, you may need some new software, you may need some new actuators to make all of this happen. But you really need to put in some intelligence behind this. So you'd need a way to predict when those peaks are going to happen so that you know when to charge and discharge. And then naturally, this does impact your process. So we designed and simulated a control system for them that would maintain a margin of safety in their water storage so that they would never be putting their process at risk. So we do the financial analysis as well as the engineering analysis. We ran all these different scenarios for them. So business as usual, they're pulling about 36 megawatts at their peak. The solar farm doesn't really help, and this is over the period of a year. So the solar farm just nominally reduces their peak demand, but it comes with a large cost of $7.6 million. So the solar farm would save them $270,000 a year. That's a 28-year payback, which if you know about solar panels, you're probably going to need to replace your whole entire solar field before that happens. If they install this scenario here, looking at a battery system, so the battery system lets you drop your peak demand charges substantially. That brings your capital costs up even higher, so $11.3 million. But now you get a much better savings, and so your payback drops a little bit to 17 years. The system that we proposed to them, if they use this smart pumping concept coupled with solar, they would drop their peak substantially. They'd still get all the kWh savings from the solar. That would give you the maximum savings of $750,000 a year, which would be about a 10.5-year payback. But really, if you just took out the solar farm entirely and just did this smart pumping concept, there's still quite a bit of financial incentive there just by minimizing your peak demand. So that one is it's less than a 1-year payback, and really this $250,000 project cost is, I think, conservative because you just need software and you need expertise. You need to tap into some of the AI and optimization algorithms that are out there so you can predict these things well. So this is one example of the services that we provide through our center. We can do these kind of more in-depth studies and present different alternatives. I hope personally to see the world transition more to the PRS, where you're tapping into the PR benefits of doing something like this. Yeah, no one may get too excited if they're not seeing the big shiny solar panels out there, but I think we need to do a lot of work collectively to highlight the low-hanging fruit that's already out there and trump these projects up so they get the attention that they deserve. So you're not just getting financial savings, but you're getting that ESG credit that you want to get. And in my mind, a project like this, if you set this up so that it was interactive with your utility, you could be doing a lot of load balancing for the utility by just using this existing asset. So that's one way that we're trying to drive the research in this direction, and we think this program nationwide could have a tremendous impact on helping to balance and maintain reliability with the huge proliferation of intermittent renewables that's happening. So the other way that we think that EGI could help is by partnering on collaborative projects. So here's a separate project. This was a fun one as well. We partnered with our local power generator, PacifiCorp. We installed AI-based optimization software at this power plant. We partnered with a third-party software vendor. I had my graduate student spend a lot of time at this facility. This is the Huntington power plant, for those of you that was mentioned earlier. So we partnered with a software vendor to do this project where we installed AI-based optimization software that, quote-unquote, learns the input and output relationships between nearly 100 different decision variables that operators have to make. And we would map those decision variables to our output. In this case, we were targeting NOx emissions. So this software learns the relationships between all those different inputs and the output of NOx emissions. And over time, as it learns and the models get better, it starts taking action and it starts solving and optimizing in real time so that we're minimizing their NOx emissions. So over the course of this project, this is how we saw their NOx emissions drop. And we're looking at on the x-axis is the range of capacity for the plant, going from 25 up to 100. And then on the left, on the y-axis, is the scaled NOx. They don't want us to disclose the actual numbers. Over the course of this project, this was about 18 months, we were able to reduce their NOx emissions by about 18%. So this plant was mentioned these are old plants. They don't want to put in hundreds of millions of dollars. This project was in response to an Obama-era mandate that these plants needed to install selective catalytic reduction technology, which I think was about $250 million for each plant. Well, we came in and we did this software project, and we were able to substantially reduce their NOx just by being smarter about the way the plant is operating. So this was funded by PacifiCorp. It was a fairly small project. What we did was we took the results and our historical successes from this partnership, and we applied for a bigger grant from the Department of Energy. This one was focused on tackling that idea of the world just being a lot less stable. And so the power plant in these years between 2016 and 2019 entered the California Energy Imbalance Market. So the value proposition for this power plant became more their flexibility rather than their ability to produce baseload power. So you can see going from 2016 to 2019, the loads on this power plant started fluctuating a lot more. So our project, we spun this off in partnership with the Department of Energy. Our project is trying to transition the way that the AI technology works, whereas prior, this neural network optimization functions as a steady state optimizer. So even though your load is fluctuating, you'll run your model here, you'll solve for the optimal conditions that will lead to minimizing heat rate in this case. But by the time you've implemented that solution and you're holding that solution, the power plant has moved. So the new technology that we've been developing is to do what's called dynamic optimization, where we're using our AI models to forecast where the plant is going, and we're building into the optimization all the moves that the power plant needs to make as it follows load from point A to point B. So we have this partnership where it's not just the University of Utah, but we've partnered with 3 companies and a total of 3 universities to make these kind of projects happen. So I illustrate that project because we think that EGI can help you and your companies. We can start with an energy assessment, we can do targeted studies for you, but really we hope that these projects spin off into something much bigger where we're partnering together to get some of those big federal dollars that are out there. So these are the 3 ways that I think your company can engage with EGI. So first of all would be get an energy assessment, you can work with us on targeted projects, and then we can partner with EGI on large federal projects. The Forge guys got me really motivated to beat their record. So there's some big funding opportunities out there right now, like a $3.5 billion total for direct air capture hubs, $8 billion for hydrogen hubs. So those hydrogen hubs are going to be on the order of about $1 billion each. EGI is engaging with a 4-state coalition to apply for a hydrogen hub, but we are actively seeking industrial partners out here who want to do hydrogen projects, for example. So that's it for me. I'm going to take a few questions and then cede the time to my colleague, Dr. Masoud Parvania, who represents our electrical engineering department at the U. Any questions for me?